Geraldine Lee Richmond, born January 17, 1953 in Salina, Kansas, is an American chemist and physical chemist. Richmond is currently the Presidential Chair in Science and Professor of Chemistry at the University of Oregon. She received her B.S. in Chemistry in 1975 from Kansas State University and her Ph.D. in 1980 at UC Berkeley in Physical Chemistry. From 1980 to 1985 she was an assistant professor of chemistry at Bryn Mawr College. Since 1985, Richmond has been at the University of Oregon, first, from 1985 to 1991, as an associate professor of chemistry, and since 1991 as a professor. From 1998 to 2001 she was the Knight Professor of Liberal Arts and Sciences, and between 2002 to 2013, the Richard M. Richmond was appointed by Governor Kits Haber to the Oregon State Board of Higher Education from 1999 to 2003 and reappointed by Governor Kulongoski from 2004 to 2006. In 2014, Richmond was elected president of the American Association for the Advancement of Science for a term beginning in February 2015. In 2014, she was appointed by Secretary John Kerry to serve as the science envoy for the lower Mekong River countries. She was appointed by President Obama to the National Science Board for a term of 2012 to 2016. Richmond is the director and co-founder of COACH, a grassroots organization founded in 1997 and based at the University of Oregon that is working to increase the number and success of women scientists in the U.S. Jerry Richmond also started a research experience for undergraduates, RU, program at the University of Oregon in 1987, and it is the longest-running RU program in the United States. In the 28 years of the RU program, it has hosted over 350 undergraduates from across the country, with 90% continuing on to graduate school. Richmond's scientific research area encompasses the chemical and physical processes that occur in complex surfaces and boundary layers. Some ongoing projects in her laboratory include understanding how water molecules hydrogen bond at a water surface and how this hydrogen bonding, which is so strong at a water surface, is perturbed by the presence of surfactants, organic adsorbents, or electrolytes in the bulk solution. These studies examine water in contact with a variety of liquid, solid and monolayer surfaces as we seek to understand some of the most fundamental interactions that underpin many environmental, chemical, and biological processes on our planet. A wide range of projects are ongoing in this area, including monitoring the adsorption of contaminants on water surfaces, studying how atmospheric gases adsorb and react on water surfaces, exploring how acids and ions in aqueous solutions alter the surface adsorptive and reactive properties at the air/water and oil/water interfaces. Characterizing the electron-hole dynamics at the surface of photoactive materials as we seek to develop high-efficiency solar conversion materials for solar cell applications. Studying the structure and dynamics of thin film growth at mineral/water interfaces. The information that we seek from these studies is important for a number of environmental, material science and energy-related challenges today. Exploring how biomolecules adsorb and assemble at liquid surfaces and the role that water plays in the surface behavior of these molecules.